In this lesson, we'll start by exploring the simplest arithmetic operation, addition. There isn't a whole lot to explore, but we'll see a solid knowledge of basic properties of addition, which make complicated-looking calculations easy. By the end of the lesson, you will know how commutative property works. The rule of thumb is we switch the numbers around the answer that stays the same. You will also learn associative property. We can add numbers, no matter how the numbers are grouped, with parentheses. The answer will always stay the same. We'll also learn identity property of addition. And lastly, we'll answer 4 practice questions. First, let's look at the picture on the left. The first row has 2 squares, the second row has 3 squares, so in total, there are 2 plus 3 squares. Now look at the picture on the right. The first row has 3 squares, the second row has 2 squares. In total, there are 3 plus 2 squares. The picture on the right, however, is just an upside-down version of the picture of the left. So flipping a picture upside down doesn't change the number of squares. So we can conclude that 2 plus 3 equals 3 plus 2. Whenever we add 2 numbers, the order of the numbers does not matter. For example, you can see that 5 plus 17 equals 17 plus 5. And 32 plus 999 equals 999 plus 32. There are an infinite number of examples. Of course, we can't write them all down. So instead, we can write the equation first number plus second number equals second number plus first number. It's a long equation to write. We can shorten it by letting A represent the first number, B represent the second number. Then our equation becomes A plus B equals B plus A. Here, A and B stand for any number, and possibly the same number. For example, if we let A equals 2 and B equals 3, then we have our original example, 2 plus 3 equals 3 plus 2. Remember, A has the same value throughout the equation, as does B. Both, however, may change from one problem to the next. Letters such as A and B are called variables. The rule A plus B equals B plus A. For all numbers, A and B is called commutative property of addition. Problem 1.1 should give you a good intuition for why it is true for positive integers. The commutative property is concerned with adding 2 numbers. What if we add 3 numbers? For each picture, we will first count the number of light squares. Then we will count the number of dark squares. And finally, we will add the 2 counts. So let's start with the picture on the left. It has 2 plus 3 light squares and 4 dark squares. So altogether, it has 2 plus 3 plus 4 squares. Next, let's look at the picture on the right. It has 2 light squares and 3 plus 4 dark squares. So altogether it has 2 plus 3 plus 4 squares. What's the difference between the 2 pictures? The only difference is the color of each middle row. Changing the color doesn't change the number of squares. So we can conclude that 2 plus 3 plus 4 equals 2 plus 3 plus 4. We get a similar equation for any 3 numbers. A plus B plus C equals A plus B plus C. In other words, first adding A and B and then adding C is the same as adding A to B plus C. The property is called the associative property of addition. Together, the commutative and associative properties are sneakily powerful as they let us add a list of numbers in any order. Let's look at problem 1.3. Let's start with the left side of the equation. To do that, we need to switch the order of the 219 and the 28. We can do so by commutative property. In other words, we replace 472 plus 219 plus 28 with the equal quantity of 472 plus 28 plus 219. This expression is close to what we want. 472 plus 28 plus 219. Whether you use the commutative property or the associative property, you get the same answer. But this is the easiest way to compute, is if you take the sum of 472 plus 28 gives you 500, and when we add what's left to 19, the answer becomes 719. So we rearrange our numbers and use our knowledge of commutative and associative properties to just go ahead and rearrange a sum wherever way is best. In problem 1.4, we can start with 2, then add 12, then add 22, and so on. But that's just too much work. Instead, let's try to rearrange the sum in a useful way. Let's pair up the numbers so that each pair has the same sum. Specifically, let's pair each number in the first group with a number in the second group. So 2 plus 38 plus 12 plus 28 plus 22 plus 18 plus 32 plus 8. The first pair of number adds up to 40. So does the second pair, third pair, and the fourth pair. So our sum becomes 160 when we add 40 plus 40 plus 40 plus 40. Let's look at one more property of addition, which is called identity property of addition. What happens when we add 0 to a number? Adding 0 to a number doesn't change the number. So in problem 1.5, we use the variable a, which is 3, and place that into our formula, and you get 3 plus 0 equals 3. And that's it. Addition isn't just about adding numbers, it's about patterns that always work the same. So keep these properties in mind and math will start making more sense every day. See you in the next lesson.